There we go. All right, so I'm recording. All right, so let's see. So today, so because I don't want to get too far ahead, I just wanted you to know that so today is the 5th. And what normally would have been due today is mod 9, but only quiz 8. Okay. And what I said about quiz 8 and the area and the average area is that I would postpone them until Thursday. Okay, so there's nothing due today, they're due on Thursday, but the following Tuesday, you'll have quiz 9 and approximate area. So I want to go over quiz 9 is in mod 9. I hope that's not too confusing for you. But what I need to cover to finish mod 9 is the integral and definite integral and average value, I think, is mod 9. Okay. Oh, fundamental theorem might be in there too. But the last one is integration by substitution. So let's where's my notes? Where'd they go? Oh, here we go. It's my mod 9 notes. Let me kill this. Okay, there's my picture.
Can you share your screen, please?
Oh, good. I wasn't sharing screen, so you didn't know how confused I was. All right, hold on. All right, now we look organized. Okay, so what was due? It's mod 9 is homework 8 and quiz 8, which are just the summation stuff. Was there any questions on that summation stuff? Any questions? Because quiz 8 isn't going to be due until Thursday, so I will go over it again on Thursday. All right. All right. So we'll leave that be. The group work that's due on Thursday is average area. So that's what's due this time is the average area. And for the average area, it was just a matter of, let me get that out for you. So in mod 9, there'll be something called area / average area. Okay. And in your worksheet, when you open up area and average area, okay, if you notice, I have, let me just pull these down. So I have A1 equals 0 and B1 equals 20. When I turn this on, you see, I see the area between 0 and 20. See how it's all shaded in nice? I could change it if I want to anything. I could change it to 15 if I like. Or I can go further. I type in 30. Okay. And then I can bring it down if I like. Okay. So those are my two endpoints, just like an average rate of change. But the graph is already done for me. Now let me take a look at what that is. So this thing here is the thing that's shading in all of that blue. There's no green because I don't have any negative numbers. If I go here, I get green. Okay, that's the negative area. Okay, so area below the axis is negative. Okay, don't need it. The one I'm looking at. Okay, the thing to note is this notation right here, the integral like that, this gives you the exact area under the curve. Okay, so the integral from A1 to B1, so that's between 1 and 25. Oops, someone at 0 and 20. Okay, between 0 and 25 is 17,833. Now the units that go with that, this. The units that go with it are miles. Miles times hours. Okay. Now, if I take that whole thing and I divide it by B minus A, that's the, so this is the area and I divide it by the length. So when I do B minus A, that's going to be 20 here. So I'm dividing this number by 20 and I'm getting that. But I want you to see something here. My original answer was mile hours. Oops. The units here up at the top would be mile hours. The units on the bottom would just be hours. Does everyone see that the hours would cancel and we just end up with miles? Okay. So what does that mean? Let me draw a picture of the line of y equals 7. Put y equals in front of here. Oops, can't do it that way. Let me only do that between that. Let me just put it this way. Okay, I want you to see that the area here, if I were to take this piece right there, it would fill exactly in this space. Okay, how do I know this? What am I exactly doing here? So if I take the whole area, this blue region, and I divide it by the length, area equals length times width. So if I divide it by the length, or in this case, I'll do the width, I'm only going to get, I'll get one value, which is the height. Okay, or the length or whatever. Okay, so that's why I get this value all the way across. That's the average value that it had. It means that if I did a little better here, I did a little worse there. And they cancel each other out perfectly. Okay. All right. So this first one here, that's the area under the curve, and the units are mile hours. The second one here, that's the average value. So I was on average 710 miles away, but I traveled 17,800 mile hours. So I'm not sure. Sometimes mile hours mean something, sometimes they don't. Like if you talk about man hours, that could be like the amount of time it takes to get a job done. But this may not be worth anything. So when you're doing your project or discussions or anything, I prefer you discuss the average value, because average value almost always means something useful. Like the temperature, if this were the temperature of the day, the value would be the average temperature. But if you want temperature hours, I'm sure there's some plants that require a certain amount of temperature hours. Actually, I kind of know this. There's blueberries or some fruits that need cold temperatures, like apples. You can't grow apples in Florida because they don't get enough degree hours below a certain number. So they have to spend a certain amount of degree hours. So you multiply the degrees times the hours. And if it's like 32 degrees below, 32 degrees for so many hours, for 10 hours, that'd be 320 degree hours. And anything less than that would be good. Anything more than that, it would be too warm and you wouldn't get any apples in Florida. They can't grow apples in Florida, it's too hot. Okay. Any questions on this? Average value, area, average value, area. All right. Take a look at it. So next time, so for this time I had the easy one, which is just the average value. The next one is where you're going to do summation then. So the next one isn't going to give you as good an answer, and it's going to be kind of much harder to figure out how to do it. Okay, but then that's the last one we have to do where we work as a group. Okay. All right, any questions? I'm not taking attendance today. Because some people think that I wasn't having class today, so I'm not taking attendance. Do you guys have a problem with that? No? Yes? You guys aren't saying anything. Hello? Hello? Okay. All right. So the speaking out loud part of so the class questions are, what is math? Let me just quickly go over some of them anyway, even though I'm not taking attendance. Here's some new questions that we have. Okay. What are the two types of integrals? Anyone? Alicia, what are the two types of integrals? Just want to hear your voice.
I have to look at that question.
No, you don't. I put it on the screen. Just read the screen.
Oh, definite and indefinite.
Very good. What do they tell you, Carlos? What does the definite and indefinite integral tell you?
Area and antiderivative.
Which one tells you which? The definite integral tells you area, and the indefinite integral tells you antiderivative. Okay, good. Where can we have negative area, Eric?
When the graph is below the x-axis, of course.
Very good. Acacia. What does sigma notation do?
Adds terms.
That. All right. Pavani. How do we use sigma notation to approximate area?
Add up heights and multiply by width.
Yeah, so we get little areas of rectangles, is what we do. Okay, Pam, how do we find the exact area? Just say,
Definite integral or infinite or many rectangles.
that's it. FTC is the fundamental theorem of calculus. We won't do that today. Okay, what does the fundamental theorem of calculus do? Okay. Do we have anybody else here? Anybody else on my list?
I can read it.
Jonathan, go ahead, read it.
It relates definite integral. I'm sorry. It relates definite integrals to definite of indefinite integrals.
Okay, so the fundamental theorem of calculus does this. It says right there, that's a definite integral. You can tell because it has an A and a B on it. So it's the area under the curve f of x between A and B. Those capital F's, those are antiderivatives. Remember, I so much as asked it on the midterm. What do those capital F's mean? They mean antiderivatives. So if you take the antiderivative and evaluate it at the B and subtract the antiderivative evaluated at A, you will get the exact area. And that is why we use the same notation for finding area as we do for antiderivatives because they're related. Okay. And the last one is how to find the average value. We just take the we just take the area under the curve. So this is an interesting thing. We take the area and divide it by the length. But look what happens when I use the fundamental theorem of calculus. See how I use those capital F's? Look at the way this looks if I replace that integral with the capital F's. What does that look like to you? What does capital F of B minus capital F of A divided by B minus A? Doesn't it look a lot like, I don't know, maybe this thing? The little f? What's the difference? What's the little, what is it when I use little f's? It means something else that has the word average in it. What is it?
It's the average rate of change formula.
Yeah. And this one right here is the average value. Okay. So you know, in my example of driving, my average rate of change could be like going 50 miles an hour. My average value, as we did, was like 700 miles. I was on average 700 during that time period. I was on average 700 miles away from home. So I drove to Florida. It was 1,000 miles away. But during that trip, I was mostly away. I was mostly far away. I was on average 700 miles away from home. Do you see the difference? Like it's same with average temperature. If you would, the average temperature is not how cold it is and how hot it is. It's the average throughout the day. Just like your average grade is, if you take all your grades and you add them up and you divide by how many they occur, that would be an average grade. Okay, but their value, the average value is not the same as the average rate. Okay. And the average rate just has the function in it. The average value has the antiderivative in it. All right. I don't know that you have to memorize that. It was just interesting. I thought it was interesting. All right. Let's take a look at some of the homeworks and see how far we get. This is mod 9 homework. Okay. So, compute the area of the integral. Okay, so they're saying, I want the integral from 0 to 6 of some function. And then they tell you this function in bits and pieces. I want you to see that this is a piecewise function. Okay, and what it looks like is this. Let me just turn it on here. Okay, so what they're saying in this function is, I want the area, let me turn this off. I want the area between 0 and 6 of this function f1. And f1 is equal to 3x, this red line here, but only when it's less than 1. So you see how the red line stops at 1. And then after 1, it becomes the function is equal to 8. You see how the function is just a horizontal line at 8? Okay. That's what the function looks like. And what we want is the area, the red area and the blue area. But I have to tell you something. I don't need no fancy integration. I can just look at this. This is a triangle, right? It has a base of 1 and a height of 3. So the red one here, the value is 1.5. 3 times 1 is 3 divided by 2 is 1.5. 3 halves. What's the blue one? It's a rectangle. It's 1, 2, 3, 4, 5 wide and 8 high. So that's 40. So this area is 41.5. Using geometry. Okay. So there's a few ways of doing it. So I can do it using geometry. I can also break the integral up into the area from 0 to 1, or the definite integral between 0 and 1, and the definite integral from 1 to 6. And I can put the function of 3x in for 0 to 1, and I put 8 in for the function from 1 to 6, because I have to break it up because they're two separate functions, so I broke it up into two integrals. Okay. And I can just get Desmos here. I just have Desmos doing it's 41.5. Desmos will do each one of those separately, or you could use geometry. That notation literally just means the area under the curve. It doesn't, that's what it means. Okay, so if you have something fancy, you'll see later on something fancy, I'll show you. If you have something fancy that you can't use, you can't integrate, it doesn't mean you can't find the area under the curve. All right, this one right here is the answer is already given, except they want you to use the fundamental theorem to find the integral exactly. So to find the fundamental theorem, you have to take what's inside the integral, make it a single thing that you can find the antiderivative of. So you find the antiderivative of it. Okay, that's the fundamental theorem. So you have to find the antiderivative of x squared minus 6. Well, the antiderivative of x squared minus 6 is x cubed over 3 minus 6x squared over 2. Okay. And then you're going to evaluate that at 4 and at 0. And you're going to subtract them. So when you evaluate it at 4, you get minus 26. When you evaluate it at 0, you get 0. Okay, so that gives you the answer that's right up there, 26. But you use the fundamental theorem. If I ask you to use the fundamental theorem, you'll have to use the fundamental theorem, even if the answer's right there. This is one of those ones like Newton's method that if I ask you, I'm not going to ask you to do a lot of things, but if I ask you to do this, you have to do it. Okay. Certain problems I like because you have to do the fundamental theorem. This one right here, you can't put in a Desmos. It's written exactly like that, but there's no answer. So you have to, in order to solve it, you have to find the antiderivative. You have to use the fundamental theorem by finding the antiderivative, which there's the function. The antiderivative is the capital F. So it's 5t to the fourth. And then you have to plug in you have to plug in x on one side. So you plug x in for the first one, and then you plug in 2 for the second one. So you have 5x to the fourth minus the antiderivative evaluated at 2, which is 80. Okay. All right. This one obviously doesn't need the fundamental theorem because the answer is right there. Okay, so for question number 6, they're just describing a region and they're saying, I want it between 3x squared. So here, if I just turn them on. They're talking about that function, 3x squared, but only up to x equals 1 and only above there. So that's just another way of saying that it wants this area right there. And that just means that antiderivative, that's a pretty easy one. Sorry about that one. Okay, so here's something I do have to talk to you about. Let me turn this off. Okay, when they give you a graph like this, and they're telling you the function, they're saying it's x cubed minus x squared. So normally you'd think, oh, well, I could just integrate it from -1 to 2. Okay, so you would say something like the integral -1 to 2 of x cubed minus x squared minus 2x dx. That's wrong. There's nothing wrong with anything except they want the area of the blue region. This function is negative for a lot. The answer is negative. Areas can't be negative. So if they say, I want the area of a shaded region, that means they want the area of a region. That means they want it positive. Okay. So there's a few ways you can deal with this. You can break it up to its positive part and then figure out what the negative part is, and then subtract the negative part. So from 0 to 2, you subtract it instead of adding it. Okay, or you could just put an absolute value in with your integral and it will automatically do it. Okay, so if you want the area, the hard part here for you is understanding all this time I'm talking about area under the curve, area under the curve, area under the curve, and here they want an area of a shaded region. It's not negative. It can't be negative. The region is not negative. So therefore you have to make it positive. Okay. Here's another one. Find the area of the shaded region. Let me turn this one off. This one's still on, yeah. Find the area of this shaded region. Okay, where'd it go? There it is. So for this one, I don't have to worry about. I could just integrate it, except, yeah, I could just integrate it. Or I could I could find the area by, there's no negative values here, so this one's not a problem. Okay, how about this one? This says find the area of the shaded region. If you're going to do something, it's got to be a positive answer. So let's take a look at this one. Okay, well, look, luckily, this one, everything is positive. So if you want to find the area, you can break this up into 3 areas. Okay. So from -1 to 0, you can just use the trapezoid, you know, where you could add up you could do a rectangle and a triangle. For 1 to 2, you can do it just a regular, it's like a square. No, it's a rectangle. Okay. But between 0 and 1, they give you the function 2 minus x squared. For that, you're going to have to do the integral from 0 to 1 of 2 minus x squared. Oops. Dx. So that answer is 1.66 or 5/3. Okay. You could do all of them that way. They're giving you all the pieces, so you could do them all that way if you want. Okay. All right. 10 and 11. Okay. All right. Let me skip 10 and 11 for now and go on to 12. It says find the average value of the function. They give you a function on an interval. So if you want the average value, you could use that formula h of, what is it, 6 minus capital H of 2 all over divided by 6 minus 2. Okay, but you have to find out what capital H is. Capital H is the antiderivative, so I have to do it as x cubed over 3, x cubed over 3 minus, oh, the antiderivative of 2 is 2x. Okay, so why is it not giving? All right, I need to make it like this. Oops. Okay, so there's the answer, 15.333. Okay, or you could find the area. You could find the area and then divide it by 6 minus 2, and you'll still get 15.333. Okay. All right. Any other questions about area? That's what you're going to be doing. So you have area. 9 and 10 are a little different. So 9 and 10. Do you remember the question? Who wants to answer my question? Alicia. I have a question. What's the relationship between position, velocity, and acceleration?
Isn't it the derivative?
So if I have position, how does that relate to velocity? Which one gets the derivative, the position or the velocity? The velocity is the derivative of position, right? And what's acceleration?
Wouldn't acceleration be the third derivative?
Second
Or the
derivative.
derivative of velocity?
Derivative of velocity or the second derivative of position. Okay? So in these questions, in questions 10 and 11, they say, find the position function given the velocity function and an initial value. So they're telling you the velocity function is this. Copy, paste. They're telling you it's the velocity. To find the position, you have to take the antiderivative of velocity. So you have to do this integral of velocity. Okay? So that means you have to do that antiderivative thing with velocity. Here's the velocity. Integral velocity dt. Okay, question. What's the antiderivative of 20? The derivative of 20 would be 0. The antiderivative of 20 is what? Anyone? Pavani? Hello? Jonathan, the derivative of what gives you 20?
T.
Yes, in this case, it's a t instead of an x. Derivative of 20x would be 20, right? What gives you cosine? And what's a derivative? What would give you cosine as a derivative? The derivative of what gives you? Go ahead.
Yes, it's sine.
The sine of t. And then there's, since it's an antiderivative, you have a constant, right? Okay, so that would be the answer, except this. Except for this, they tell you S of 0 equals 4. So they're giving you that. So if I take this thing and I just copy it down. Okay, so let me get rid of all the work in between. So I have S of t is equal to this, right? But if I plug in a 0, that would be 20 times 0. And that would be the sine of 0, right? Plus a constant. And that's supposed to equal 4. What's 20 times 0?
0.
And what's the sine of 0? Do you remember? 20 times 0 is 0. Sine of 0 is 0. So what's 0 plus 0?
0.
What? So 0 plus c is just equal to c, right? So on this side it equals c, and on the other side it equals 4. So now we know what c is. Okay. So if we want to know what the position is, position is equal to that plus 4. Okay. If I take the derivative of it, I take s prime of t, what am I going to get? I'm going to get 20. Derivative of sine is cosine. And the derivative of 4 is 0. Okay. That 4 is only because they told us what's called an initial value. Okay. All right. Now, the difference between 10 and 11 is you have 2 initial values and you start with acceleration. So to get, if you want to get position from acceleration, you're going to have to do one antiderivative and then another antiderivative. So you're going to do the integral of 8 minus t dt So you're gonna do that. So that'll give you, what's the antiderivative of 8, Jonathan?
8t.
T, very good. And Acacia, it's the antiderivative of T. There. It's T squared over something. Remember, it's the power rule for antiderivative.
T squared over 2?
That's a constant. Okay, and that's velocity. So that's V of T. Okay, so now they tell you that V of 0 equals what? Well, it's 4. So when I plug 4 into this, I take this guy here, copy. 4. I'm gonna get. Oh, it's V of 0 equals 4, V of 0. So I'm gonna get 8 times 0. Just gonna be 0. And then I'm gonna get 0 squared over 2, which is gonna be 0. And then that constant is just gonna be equal to 4. So the constant is 4. See. Okay. But we're not done. Now to get the position, we have to do this again. Equals the integral of this thing. That's a 4. Okay, so you have to do the antiderivative. So whatever that is, that's going to give you the position. Okay, so it'll be something like 8t squared over 2 minus, that's going to be t cubed divided by 3, but there's a 2 down there, so 3 times 2 is 6 plus 4. Okay. All right. That's it. That's all the homework. And now you should be able to do those questions. You have to do the last step, but since that's S of 0 equals 0, it's just going to be, the constant's going to be 0. So that's the answer right there. Okay. All right. Let's see what the quiz 9 is not due until the following Tuesday. Let's see what it looks like a little bit. Okay. What are the 2 types of integrals? Who had that question? What are the 2 types of integrals? Was it Alicia who had those 2 questions? What are the 2 types of integrals? No, it wasn't. It was Carlos, and he's left.
Oh, I got that question.
Oh, you did. Okay, what are the 2 types of integrals?
Definite and indefinite.
Very good. Say the following. I didn't go over any says. I'll go over more says next time. What's the ddx mean? Right, you should know that because from the other part, when you put a d over dx, it means d. It means the derivative. And then the other part is the integral. So it's the derivative of the integral from 0 to x of the given function of t equals, okay, there's no sum there. So it must be this one. The derivative of the integral from 0 to x of the given function of t is the given function of x plus c plus a constant. That must be it. Okay. What happened in lines? Uh-oh, I missed the lines. 14 and 15. Oh. It looks like they found that's probably the fundamental term. That looks like the antiderivative of the function. And then up here, they solved it. I would say that's what 14 and 15 is the fundamental theorem of calculus. Okay. Find the position and the, oh, that's the one we just did. I don't know what it is, but I'm not going to do it. So I'm going to get it wrong. Because that one I actually have to do. Okay. Here's the distance away from, find the average distance from home between hour 1 and hour 16. So click on this. Oh, look at that. They don't. Oh, no. So the average distance, I'll do the integral from 1. What did they say it was? 1 to what? 1 to 16. So I know this is an integral from 1 to 16. I know the function is f of x dx. That's not the average value. To get the average value, I have to do what? Divided by what? I'm not answering this question. Someone's going to tell me. I'm waiting. I'm waiting. I'm waiting. I'm falling asleep.
Can you repeat the question one more time?
We're looking for the average. We're looking for the average distance. So this is an average value. So I found this right here, which is going to be in mile hours. So I have to divide, in order to get an average distance in miles, I have to divide it by hours. So which hours are we going to do? It's between, it says it's between hour 1 and hour 16. So how many hours are we going to put here?
15 hours?
Exactly, 16 minus 1, but yes, 15. Okay, so now let me have Desmos do it because I don't want to do it. So I'll take out these units. It will tell me what the answer is. Come on, go, shoot. And the answer is 490. 490 miles. That's my average distance from home. Oh, find the answer to 2 decimal places. 490.20. I guess not. Anyway, it's not working. That's what you have to do. I don't know what's going on here. I think I've lost my connection to this. You all can still hear me, can't you?
Yes.
All right. I think that's the end of what I wanted to cover, and I didn't want to go past 7. So, are there any questions on this? I would break you up into your groups to work on things, but not everybody's here. So I will do it on Thursday. And I will finish covering anything else from this mod 9. You might want to go over, practice some of the antiderivatives. You should be getting a little more comfortable with those antiderivative properties. Understand what it means to be the area under a curve. So, all right, I went over the homework, but you can continue to go over those answers. I can't do anything, so I have to stop. Okay.
Professor, one more thing. Under mod 9, I don't see a harmonized link for the discussion.
Oh, but there will be by Thursday. We haven't done mod 9 discussion yet. Right? Maybe we did.
I thought
Did
you
we?
said that one was due Thursday.
No. Oh. No, mod 8 is due Thursday. That's the one with the average value, yes, but it might go to mod 9. Okay, I'll fix it. I can't do anything. I'm gonna have to fix it later. I'm literally getting a bunch of maybe that fixed it. Okay. I don't know. I'll have to fix it. It'll show up. Okay. Anything else before I let you go? Carlos, Eric, Pam, go out and vote. Did everyone vote?
Yes, we
Yeah.
did.
We still have an hour and 15 minutes. Pennsylvania's not far away. Anyway, all right, I'm gonna let you go. I will see you next time. Anything else? I'll hang around afterwards, otherwise y'all can head out.
Good night.
Have a good
Good
day.
night.
Happy election day.
Thanks, Professor.
Take care, bye-bye. Pavani, do you have a question for me? Hello? Okay, I guess you don't. I'm closing up the shop.